Okay, here I'm going to demonstrate how to use the 7-segmental LED displays. So as you can see here, this is a simple 7-segment one-digit example. So 7 segments are used in area. You can, if you go to a supermarket, if you try to check your balance after paying, or if you hang a weight scales, or in some shops on displays and area, you can find the 7 segments, right? They could be LED type, or they could be sometimes LCD type. So they have wide variety of applications. So 7 segments are used to demonstrate any number, decimal number. For example, if you want to show uh, number 3, you have to just turn on this A, B, G, C, and D sequence. So it must display number 3. So if you want to display number 1, so B and C can be light up. So there are, you can see 1, 2, 3, 4, 5, 6, and 7 LEDs. That's why it goes 7 segments. And so if you want to select a particular light or multiple lights, you can have 2 configurations. You can buy 2 types of common, 2 types of 7 segments. The first one is common cathode type. Here, this all the 7 LEDs, the cathode of the all LEDs are connected to make a common cathode. So you just need to provide positive 5V supply, and while you have connecting this to ground to eliminate any light. So the other configuration is common anode type. So the positive, the anodes of all the LEDs are connected here. So you have to provide positive 5 supply here, and you have to connect this A, B, C, or any light to the ground to light up the required light, right? So here you connect this common to the ground and provide positive 5 or any desired voltage, safe voltage to here to light up here. Here you provide it to the positive supply and connect this to the ground, right? So for different number sequence, there is a different light pattern. For example, in order to display number 0, A, B, C, D, E, and F can be light up. So you can see here, A, B, C, D, E, and F can be light up to display number 0. Likewise, up to number 9, there are different sequence. So the programmer should be know which sequence to be light up for any particular digit. Now, this is the schematic. All the others are the same. This is a 7-segment IC. This is LSHD A103 common cathode type. So pins, there are 10 pins. So pin number 1 and 6 are connected to the ground, and pin number from 2, 3, 4, 5, 6, 8, 9, and 10 are connected to the light sequence like A, B, C, D, E, F, and G, right? And dp is the decimal point. If some common segments comes with this small dot here, sometimes you have to show like a decimal place. So you can also light up this small dot here, right? But in this example, I'm not going to use that one. So I'm going to just show you the data sheet of this one. So I have just downloaded this Lighton Optoelectronics. So these are the dimensions. So it's a common cathode configuration, you can see. So pin number 1 stand for common cathode, and pin number 6 is stand for common cathode. And for pin number 2 is for anode of F, 3 is for anode of G, likewise it's displayed. There are some electrical characteristics as well. So it doesn't need much in this example. If you use like a 330 ohm resistor like in the previous LED light sequence, so it will be safe. Okay, so the code is for this one. So I'm just increment the light by 1, like this starting from 0, then 1, 2, 3, and 4. once it hits to 9, I'm going to start from going to jump back to 0. So this is my code. So as you can see here, I have connected port A to the 7 segment. So I have to set it as output. So I'm using a function called display number. So number is a integer. I have defined it as 0 initially. So display a number and make a delay of 1000 milliseconds. So it's starting from 0 and display 0, call this display function. And after returning, make a delay and increment this number by 1. And if the number goes to more than 9, which means if it goes to 10, again, the number variable should be set to 0, right? So let's take a look at what is this display function means. So it is a switch case. So it's a void display integer I. So it's calling this internal, copying whatever the number you copy to here. This number is copied to here and it's copied inside to this function calling as integer I, which is local to this function. So once you call with integer number, so it is copied to this internal integer I variable and checking with this switch case, right? If this I, like if it is 0, case 0 is called, which is set to port A is bit sequence, corresponding bit sequence for lighting up this 0. And after that, it will break. So if the number is 3, it will call this one and make the light sequence to number 3 and break. So likewise, I'm just make with the delay of 1 second. So I'm incremented from number 0, 1, 2, up to 9, and it's starting from 0. So this can also be a very simple one. So you can buy this command and node type 7 segment from the market, very cheap. I put it on a breadboard using 330 ohm resistors coupled to Atmega 16 microcontroller. And you can try to write this code and compile it and get the hex code and burn to this one. So you can test this one. So if you have any simulation software, you can try this, implement it, and test this code by importing the hex file to the microcontroller and see how it works.